Welcome everybody. Welcome to our webinar on deploying and maximizing FME Server. Take it away, Jen. Why don't you introduce yourself?
Yeah, so hi, my name's Jan. I'm a cloud support specialist at SAFE. So I do all of the cloud support for FME Cloud. If you're deploying FME Server on the cloud or connecting to the cloud or doing anything with Docker and Kubernetes, you'll probably encounter me.
That's right. That's right. So Jen does a lot of good work figuring out all this technology, is a deployment expert. My name's Don Murray. I'm one of the founders of SAFE, and I spent a lot of my time thinking about server and making it able to handle more and more enterprise solutions. And I get to work with an amazing team, both at SAFE, but also an amazing team of partners and customers around the world. So first off, a little bit about the agenda here. We're just going to take probably 2 minutes just to give some context on SAFE software and what the FME platform is all about. And then we're going to dive into some of the things that you need to understand in order to help you maximize the deployment of FME. So first off, it's important you understand your workflows. So whether you're starting with FME or you have an existing FME, understanding those workflows is really key. Then we're going to talk about a few of the processing options you have with FME Server and how you can leverage those to maximize your return on investment. Then we're going to talk about the deployment options, and Jen's going to take us through all of those. And then last but not least, we're going to have some demos where we're going to show, Jen and I will go back and forth, showing some of the deployments of FME Server in action. Yeah, so a little bit about SAFE software. We've been working with data, particularly spatial or location data, for about 25 years, over 25 years. Our business is we help organizations maximize data, and as you can see, we've been very successful helping organizations around the world. So you can see there are 128 countries sell FME, and the way we work is we have a partner network. SAFE focuses on building the product, supporting the community, having a bunch of experts like Jen who support both our partners and our customers, because our partners can deliver expertise face-to-face around the world, and there's nothing like being able to meet somebody local who really understands FME, who can just take your experience to the next level. The FME platform has essentially two major components. The FME Desktop is where you build your data flows, connecting to databases, files, other systems, and move data, combine systems, just supporting a whole range of different data types. The server is what we're going to talk a lot about here because it is the one that has the deployment options. FME Desktop is a desktop application, as the name implies, and so it runs natively on either Win32, Win64, Linux, or Mac OS, and is a single machine deployment. FME Cloud is FME Server hosted, and so we're going to talk a little bit about that because it in fact is one really easy and attractive way to deploy FME Server. So the desktop is no code, so you don't have to code in order to pull data together, and that really is one of our strategic advantages compared to other applications. Data cleaning, validation, of course, is one big concern that everybody has, and FME has some tools for that as well. Server.
So once you've built your workspaces in FME Desktop, you can publish that up to FME Server, where it basically gives you so many more options around how you run those workspaces. So you can see here, you can build your enterprise sort of applications around them. You can create schedules, you can create web applications, you can build automations in a GUI, just like Workbench, where there's no code, you connect things together, which you can see in the screenshot here. You can also scale out your FME Server deployments. So FME Server runs on engines, and each engine will process one job at a time. So it's really easy with FME Server to scale out and add more engines if you want to be able to process more workspaces at once. Cost effectively deploying your processing close to the source, and that's going to tie into a lot of what we're talking about today with your different deployment options.
Yeah, so why FME Server? When people purchase FME Server, there's a number of benefits. The first one is by automating these tasks through that no-code interface, you're able to save a lot of time. And our tools are so powerful, you can automate not just the simple tasks, but also the quite complex tasks, and we're going to talk a little bit about that. Save money, of course. Now you have one tool that's very cost effective compared with other tools, but it can handle all types of data. There's other enterprise solutions out there, but they do not support location data. And with that growing in importance, that means you're probably going to need to purchase FME anyway. And the thing about FME is you can actually do it all, save money on training, and you're going to find when you look at the cost of our platform versus others, you're going to find it very, very attractive. Improved data quality. Data drives decisions, and the higher quality of the data, the better your decisions are. So it doesn't matter what organization you talk to, they're always concerned about data quality and how they can enhance the data quality, and that's another strength of FME Server. Again, last but not least is we say we make the impossible possible. No other system is able to connect to so many different systems and so many different types of data and combine it in new and wonderful ways to give you new insights into your data and drive new decisions.
So our goals for today, whether you already have FME Server, and maybe this will be something to consider when you come to upgrade your versions, or if you're new to FME Server and you're getting started on your journey with FME Server, this webinar will allow you to understand the value, benefits, and differences of all the different FME Server deployments, so you'll know which one is the right one for you and your organization. And you're also going to see some of those deployments in action.
Yeah. So one big question you always have when you're deploying FME Server is which FME Server, where should I deploy it? And there's so many things. It's where's the data is one of them. And so we're gonna look at all the options. How can you deploy in the cloud? How can you deploy on premises? How can you tackle large processing tasks that might come up periodically? Or maybe you have an FME Server that's got whose load varies greatly during the day or the week. And last but not least, we're going to talk about how you can easily set up an FME Server for prototyping, learning, testing the latest features of FME Server.
So our deployment options enables you to deploy wherever is best for you. So we're going to have a look at all of these different options, from self-hosted if you're installing it on premises, cloud-hosted with FME Cloud, or our cloud marketplaces. And then lastly, we're going to have a look at the containerized deployments, so Docker and Kubernetes. And maximizing your deployment depends on a few things, which you can see on this slide. So we're going to go into understanding your workflows, both the ones that you're already running and the ones that you're planning to implement in the future, looking at where your data is located, and also the applications that you're connected to. So a lot of people will be connecting to databases. Where they are is important as well. And also understanding the different FME Server processing options.
So the first thing that's really important as you're designing or maximizing your FME Server deployment is understanding the workflows, as they're definitely key to helping you maximize your deployment. And the thing about FME Server is it has many different ways that it can help you with your enterprise workflows. Do you have real-time events? These could be events coming from one application that's to trigger work in another. It could be an event from data arriving. Maybe you want to do something when something arrives in an S3 bucket, or on an FTP site, or in a file directory. Or maybe you have different types of real-time. Maybe you have real-time high-speed data streams that are coming from devices or IoT or applications or some other data streaming system. And so with FME Server, you can handle both of those real-time events. The next one is application integration, connecting applications together to reducing manual workflow. Scheduled tasks, how many scheduled tasks do you have? Are they doing simple things like running one job, or are they triggering complex tasks that could be an automation with many, many steps? Are there any FME Server apps? Again, FME Server apps put a load on the server that depends on the users who are using the app. These are no-code applications to support users across an organization who, when they're using them, they don't even know that FME is behind the scenes. And last but not least is with the growing importance of mobile apps and the work we're doing with FME AR, do you have any mobile apps in the field that your users are using who are going to request data from the server periodically?
So when it comes to understanding your workflows, you can take a look at the different types of ways you're running jobs on FME Server, like Don just mentioned. But I think the key thing that they're going to come down to is, like, do you periodically have big processing tasks or things that are putting a lot of load on your system? So for example, if you're doing real-time data streams, but perhaps data isn't being streamed through all the time, that will probably choose which engine you're using and maybe which type of deployment you're using. So once you've had a look at your schedules, your automations, your real-time data streaming, or your FME server apps, think about if these have busy times or if the workspace load is a lot more predictable and a bit more steady. Something else that you need to consider is also whether you have operating system or third-party library dependencies. So for example, if your FME server or your FME workspace requires you to install another application, something like FME Cloud where you don't have access to the actual virtual machine itself isn't going to work in that case because you don't have access or permission to install an application on FME Cloud. So that's something to consider, as well as if your formats that you're using have operating system dependencies. So if you're using Windows-based formats pretty regularly and you need to keep using them, you're going to want to stay away from the Linux deployments because that won't work for your workflows. And then data location is also key. So we want you to put FME Server or other FME Server engines as close to your data or the applications that you're integrating with as possible. So if your systems and data are on premises, then it probably makes sense that you're also going to install FME Server on premises so it's close to your data and applications. And then if your data or applications are in the cloud, then you're probably going to want to install FME in the cloud, but not just anywhere in the cloud. So you can see here, this is a map showing the Google Cloud Platform's locations and networks. The blue lines are their existing network. So just because you have applications or data in the cloud, let's say in Europe, doesn't mean that deploying FME Server in the cloud in North America would give you any benefits. You can see on this map like how long the lines are between North America and Europe. So you want to make sure that if you're deploying in the cloud, you want to put it in the region that's ideally the same region or as close as possible to where your data or applications are.
Mm-hmm. Mm-hmm. The other thing that you need to understand when you're working with FME is the different processing options that are in FME Server. And so there's two of them we're going to look at, and here they are. The first one is, this notion of standard engines. And what an engine does, for those who are new, is an engine defines how many things can happen at once. So if you have one engine, then you can run one desktop workspace at a time. Now, so that may take 1/10 of a second, it may take a day. It depends on the work. And so those are the traditional ones. You purchase FME standard engines. They're sold by the engine. So if you buy 5 engines, you own them, and you can do whatever you want with those 5 engines over a year. If they're idle, they're idle. They don't cost you any more. If they're really busy, they're really busy. So of course, the point of them is you really want to work to keep your engines busy, because when you're not using them, then you have unused capacity, which is costs us money. On the other side, we've introduced this notion of dynamic, and what this is about is the ability now, you do not buy engines, you buy time. And so in this one, you would buy a block of CPU hours. It's billed to the second, and in this case, you can spin up or down as many different engines as you need, and it depends on how much work that's getting done is the key. Also, they both have exactly the same capability. We often get that question, do dynamic engines have less capability than standard engines? And the answer is no, they're exactly the same. It's only the billing model that is different, giving you the choice. Yeah, so again, delivered based on usage, based on CPU time. So if you have an engine running, but it's idle, not doing work, then it's not costing you anything. So the benefits really are, now you're flexible to have as many of these engines there, because you're only paid for the work that's done. And these are, you're going to see in some of the modern deployments like Kubernetes, serverless, things like that, where basically the whole notion is to scale up and scale down, so you have capacity to meet the workload. In order to maximize your effectiveness is where is the key. When it comes to data streams as well, you might have a data stream, as Jen said, which is sometimes really busy and sometimes really quiet. Well, you could dedicate a dynamic engine to that, because when the stream is very quiet, that you're not paying for the CPU time. You're only paying for the CPU time, and during those quiet times, there's not going to be any CPU time. because you're only doing CPU when you're doing work. So if you're deploying FME Server, definitely worth a serious look. Yep. So in summary, you only pay when work is being done, not when the dynamic engine is idle, or even in a workspace if it's waiting for data. So take a look at that, and definitely worth a look. And the thing is you can have as many dynamic engines as you want idle, just sitting there ready for work, and there's no charge for that.
Okay, so now let's take a look at the different deployment options. So this is probably the most common one, is the self-hosted deployment. So you're responsible for installing FME Server onto your own hardware. So that could be in the cloud, you go and install it yourself in the cloud, or perhaps you have virtual machines set up on premises that you're going to install on. And with this option, you're responsible for everything. So things like security updates, if you need to scale or add more components to FME Server, you have to go and do that yourself, probably manually. But some of the benefits of this is you are in complete control to customize as you want. And if you've got existing hardware or you've already invested in virtual machines, you can use those investments to install FME Server. Next is FME Cloud. So with this deployment option, we've already installed FME Cloud on a virtual machine in the cloud for you. You don't have access to any of the backend, any of that virtual machine. You only get access to the FME Server web interface. So it's really quick to get up and running. Normally an instance will launch within a few minutes, and FME Cloud will do the server maintenance backups and ensure uptime for you. And FME Cloud is also, I'd say, the only FME Server deployment that has a different licensing model. So with FME Cloud, you're paying for time per instance size. So if you've got a really big instance, that's going to cost you more every hour than a smaller instance. And you can run as many engines as you want on an FME Cloud instance. You're just constrained by the hardware that it's running on. So if you're on a standard instance, which is a smaller instance, if you try to add 30 engines to that, I mean, the FME Server web UI would probably let you, but the underlying machine probably would have a bad time if you did that. So our cloud marketplaces, these are if you want to install in the cloud pretty quickly. So we've already set this up so you can launch FME Server in just a few clicks. You don't have to go in and run the installer manually like you would if you're self-hosting. But with this option, you still have to understand and plan for security updates, scalability, and performance. So some of the benefits with this one is it's really easy installation. We've already set up the virtual machine images for you. You can launch this within your own private network, and you can take advantage of dynamic engines. And we currently have marketplace offerings on both Google Cloud and Azure. So on both platforms, we have an FME Platform Deployment. So this is a virtual machine that contains FME Desktop and FME Server for those maybe who are newer to FME and want to get started authoring their workspaces in Desktop and publishing it straight to Server. On the Azure Marketplace, we also have a distributed or fault-tolerant deployment. So with that one, we're making use of virtual machine scale sets for both the FME Server core and the FME Server engines. So you can not only scale up the number of engines on each machine, but if you want to sort of go beyond the hardware of that machine, you can use the virtual machine scale sets to add more virtual machines, which gives you more processing power. And then lastly is containerization. So we have quite a few customers and more customers all the time using these deployment options. So Docker is typically done on a single host. You'll run your containers, and by single host, I mean sort of one machine. Kubernetes allows you to install FME Server or multiple applications across multiple machines. And Kubernetes will do more of the container management and orchestration for you, whereas Docker, it's a bit more of a manual process. But containers are typically faster to deploy than, say, virtual machine images, and it's definitely a lot quicker than going through the installer yourself and doing that.
Okay, now we're going to look at some of the deployments in action, and yeah. So really, the summary of all this is there's definitely an FME Server deployment that meets all your needs. So reach out to us after. The first one is going to be FME Cloud. And here we'll show how easy it is to get started with FME Cloud. Very quick installation, no hardware, unlimited engines in quotes, because it depends on the size of the instance. The bigger the engine, the bigger the instance, the more engines that you can launch. And of course, flexibility and the security again is, we look after that because you don't have access to the underlying machine. So let's look at our demo here. So the goal of this demo is just to show that this is really the simplest way to launch FME Server in the cloud. The high points of this is, your load is predictable. You know the size of the machine, that the instance you're launching is enough to handle the highs and the lows of your load. The data, of course, as Jen talked about, data gravity is a real thing. And so your data is mostly in the cloud. And so, you wouldn't launch an FME Cloud instance if your data was always on-prem. And it has easy vertical scaling. At any point, you can simply select a different size of instance and scale up to handle the peaks. And then you could also scale down later if you needed to. And of course, again, if you know your data is in the cloud, you want to launch FME Cloud into a region that is close to your data. And the result is that FME Server is up and running in minutes. And then you can, it's a full FME Server, so then you can able to, take all benefits of all the features of FME Server. Okay, so now we're going to do the demo. Okay, so I'm going to show how to launch FME Cloud. So to do that, you simply type fmecloud.com and you'll be redirected. Already a customer, you can get a sign up and get a $250 credit. So I'm going to go here, and it takes you to the FME Cloud page, and you can figure out how to start for free. Tells you what you get, the $250 credits, and then some of the use cases and benefits. And so I already have an account, so I'm going to log in. I'm going to use my Google, of course. There we go. And enter my 6-digit. And so now I'm just going to go here, and I'm going to launch a new instance. There. Next. And here's where I can pick the version I want. Let's say I want to test the latest beta, so I just click there. And so now I'm going to install the latest beta, and then here's where you can pick the size of the machine. If you're a free license, I believe you have the bottom 3. Contact us. So you can see you get a very big machine all the way down to the smallest machine possible. And you can also pick the region. So, and if there's any regions that are not supported, let us know. And we add them based on demand. But you can see we have the US, Canada, 3 in Europe, 1 in the UK, and then 1 in the Southeast, so Sydney. And you simply pick the size of your disk. The thing to remember with that, we're running on Amazon, so the thing to remember is the bigger your disk, the faster the performance. So you can either use a slider, or you can just type, say, the temp disk, and then how do you want to do the security updates? They're automatically applied. Another benefit of cloud. Sometimes you have to restart, and so you say next. And that's it. It's going to tell you you're going to get some alerts, and then you simply launch. And okay, and it gives you this nice summary here. I just went for a small machine, so it's going to cost me, if I left it running 24/7, it would cost me $690 US per month. So obviously, if I pause it and that sort of thing, and then I can go longer. So I'm going to launch, and this will take, depends on the order of about 10, 15 minutes. And okay, there you go. It's running. So that took about 10, 15 minutes, and now I have a full FME server. So there you go. If I want to launch and log into it, I simply click here, and I'm given a URL. So I'd simply download the credentials to be able to log in. The other thing I'm able to do, which is really handy, maybe I only need my my FME server at certain times, so I can create a schedule. and I could say that I want to start and stop my instance. Okay, so or you can start it and stop it. So you could specify, when. So this would be my schedule, weekday. I could pick the days. I could say Monday to Friday. I wanted to start at 7 in the morning, and I wanted to finish at 6 at night. And then I would simply say save. And then you would save. Now, for some other interesting workflows, is you can schedule a time for the instance to start, and then you could have it start, perform a task, and then using the REST API, you could actually have the task, when it's completed, shut down your server. And that way, if you have a periodic task you're not quite sure, maybe some heavy lifting, you could have a time when your machine starts, have it process the task, and at the very end, you could have the task running, shut down your instance. So we have customers doing that. Or you could just schedule a stop time. Maybe you know it's a machine that's used periodically, but it needs to be shut down. But sometimes somebody might forget to stop it, and so you can do that. So that's the other thing that's really handy with this. When you look at the instances, if you wanted to resize it, so that's the other thing. Maybe, normally a starter, which is this, the really small one that's great for prototyping and that sort of thing. But maybe you need to resize it. So you can simply click on the resize. You would pick your instance type professional, for example, and then you would click resize, and then in a few minutes later you would see that it's resizing. Okay, and there you go. Okay, so our next one, we're going to look at containerization. So we're going to show a number of demos. I'm going to show the Docker Compose. This is a simple container-based deployment that I run on a single machine. So it is supported. And I use it for testing, pilots, proof of concepts, learning, and prototyping various new features. So if you have FME Server, you can use Docker Compose to deploy it to production. If you want to use Docker Compose to deploy it to production across multiple machines, you can do that as well. It's a great way to test out new features with a very low machine requirement. So in this demo, we're going to show the goal of this is to create an easy to deploy multi-engine FME server on a single machine. Or of course, you could distribute across several. In this demo, I'm just going to stick with one machine. And this could be for production or for quick testing, learning, and prototyping. The obstacles that this overcomes is installing and configuring any application on your machine. Sometimes they interact with other applications. By having this inside containers, it really makes it easy to control and easy to configure. It's literally one command and it goes, just does it all. So yeah, so FME Server using Docker Compose. It's also a great way to try dynamic engines. Okay, so now we're going to do the Docker Compose demo. Here I'm going to show how to launch FME Server within containers. I'm going to use Docker Compose, as this is what I use to launch it onto my MacBook Pro for testing, prototyping, and that sort of thing. So if you're looking for a way to deploy FME Server really quickly and easily, then this is a great solution to consider. We do have some that have actually deployed this in production too, so it's a fully supported offering, but it's just a great way to prototype and run it anywhere. So I'm just running it on my laptop. So here we go, free trial. Go to server, select containerized, and I'm going to choose Docker. Simply, it's lighter weight on one machine than running a Kubernetes cluster. So I click instructions. This opens up a community knowledge base article, and our community is a fantastic spot for technical information on how to go. So you can see lots of interesting stuff on the side there. I'm going to say FME Server for Docker, and I'm going to grab the latest beta that's been put up. Click there, and I simply download this Docker Compose.yaml file. That's all I do. So I simply download that, and now it's downloaded. There is in fact no FME server on this machine, and so I just type localhost, and boom, you can see that in fact there is no FME server on this machine before I start. The next thing I'm going to do is I want to also play with dynamic engines. So to do that, I need to edit the docker compose.yaml file. And you're going to see as you scroll down that by default, dynamic engines are not enabled. So what I'm going to do is I'm simply going to delete this. And so there we go. So now I'm going to save that. And that's all there is to it. So now when I launch my server, I'm going to have, it'll by default, it'll come up with one dynamic engine and one standard engine. Okay. So now I'm going to go over to terminal. And I have my Docker Compose there. And so now I'm just going to go Docker Compose. Used to be one command, now it used to be by itself. Up -D, because I want it to be quiet. I don't want to see everything. So I simply do that. And then it's going to start the FME server. So you can see now I have the FME server started. And so now I'll go back to Firefox. So I type localhost, and there you go. It's already up. I don't have my certificate set up, so I'm just going to go through, accept the risk and continue. And now I have FME server running. And there we go. Okay. And if I look at the engine management, I see that I have one standard engine and one default engine. If I look at my system configuration and licensing, you see I have two standard engines licensed, and because this is an eval, and I have 100 hours of dynamic engines. Okay, so now if I want to increase the number of dynamic engines to 5, I simply enter this command here, docker compose up -D scale, and then I specify the number of engines I want. I hit engine and or enter, and there we go. I have 5 engines running. Here we go. And so now I refresh this, and you're going to see, you see that I have 5 dynamic engines, and I have my full FME server with all the different capabilities. So there you go. That's how easy it is with Docker Compose to build and deploy FME server on your own machine.
So now we've had a look at Docker, which is running containers. We can move on to Kubernetes. So Kubernetes takes containers to the next level and was developed to solve the problem of manual container management, and is considered a container orchestration tool. So it lets you pool together resources and abstracts the hardware, so nodes or hosts, so you manage them from a single place. So just to give an example, comparing what Don mentioned with the Docker, Docker is typically installed and you'll deploy FME server on one machine. If you wanted to, and I'm not recommending this, if you wanted to sort of put some Docker FME server engines on a different machine, maybe leave the core on another one, you have to do that a lot more manually, and you have to go in and install them on their separate hosts differently. With Kubernetes, you don't have to worry about any of that. Kubernetes does that all for you. And Kubernetes is also resilient, so it will repeatedly check the health of your containers and restart them if they're unhealthy to make sure that you're kept at your desired state. So if you've told Kubernetes you want 5 engines and 2 cores, if Kubernetes sees that one of your engines has gone down or it's become unhealthy, it will do its best to restart it. And while it's unhealthy, it also won't send any traffic to it. So if you've got jobs that you're submitting, Kubernetes will make sure those jobs don't get submitted to an unhealthy engine and you've potentially lost your work or your job. It also has smart bin packing, so it will distribute its resources across nodes based on CPU and memory requests. So you can also request that specific pods or containers are scheduled or not scheduled onto specific nodes, which we'll have a look at in a moment in the demo. And you also install FME Server with Helm, which is a package manager for Kubernetes. And I've just added this big warning on this Kubernetes slide, just to say that this is probably the hardest deployment that we've talked about today. So if you are interested in containers, I definitely recommend starting with Docker. There's definitely a learning curve from just doing the installer like self-hosted on premises, which most of you are probably used to understanding and sort of troubleshooting these container deployments. So I know when I first started doing all of the cloud support, Kubernetes and Docker was really tricky. There's a lot to understand with how it works. And with Kubernetes, you have to set up a cluster before you even get to installing FME Server. So I do recommend, if this is something you're interested in, take the time to learn and understand it before you jump right in, or you'll probably have a bad time like me. So with the Kubernetes demo, we're going to show an FME Server deployment running on Kubernetes, show how easy it is to install FME Server on Kubernetes and how low effort it is. But note, I have put the warning that this is low effort in the demo because I've done all the hard work setting up the cluster beforehand. So as part of this, we're going to be setting up a script and writing a file that contains all of the information about our deployment to use. And then we're going to have a look at the result and we'll see how Kubernetes starts up all the right containers and pods for our demo.
So let's take a look at FME Server running on Kubernetes. So I've got two windows open here, which you can see. If you're familiar with FME Server already, you'll recognize the engine management page. And on the right-hand side is where I control the deployment through Kubernetes. So on the top right-hand side, I have my values.yaml file, which is where all of my sort of properties for the deployment are kept. And on the bottom of that is a terminal window, which is where I interact with Kubernetes through the API. So you'll notice in my FME Server engine management page, I have 3 standard engines currently running. And you can see that that is actually defined in this values YAML file. So I have this standard engine group here with 3 engines, and the type is set to standard. With Kubernetes, you can group engines together. So if I wanted to start more standard engines, I could just edit this standard engine group. So for example, the next time I'm going to change my deployment or upgrade it, I might just move that down to 2. And then what I'm actually going to do is increase the number of dynamic engines that I have. So because dynamic engines are different to standard engines, they belong in a different group. So I have this dynamic group here, and you can see I've set the type to dynamic. Currently the engine count is set to 0, but I'm going to increase that to 2. And then if we want to apply those changes to our deployment, we just make sure that we've saved this file. And then using the Helm upgrade command, that will take that values file which we're passing in and make sure that Kubernetes deployment is now reflecting what is set inside this file. So now we can see pretty quickly that our dynamic engines have appeared. I've got these 2 dynamic engines that have appeared here. It will take a little bit longer for the extra standard engine that I have to disappear as Kubernetes terminates that pod. But if you keep an eye on that page as we keep going through the demo, you'll notice that that will drop down to 2 standard engines. Something you might have noticed in the values YAML file is that there are a few extra properties set for the dynamic group compared to the standard group. And these are the node selector and the tolerations. So as I mentioned when we were going through the slides, Kubernetes allows you to abstract the hardware, and you don't really have to worry about the nodes that the Kubernetes is running the pods on. This is because you can sort of control this with your YAML file, and also you'll do that when you're setting up your Kubernetes cluster. So because I'm going to be running dynamic engines, and because they are dynamic, it's not always predictable how many dynamic engines I'm going to be running at any time. So I've set my dynamic engine group to run on a particular set of nodes, or a node pool, as Azure calls it. So in my Azure UI, if I go back to this page, you can see that I have 2 node pools currently running. The agent pool has just a standard general virtual machine type, which is this node size here, the standard DS2. And this is going to stay pretty static. So I don't have auto scaling enabled. If I want to change the number of nodes in my cluster for this particular node pool, I have to do that myself. But as I don't expect the number of standard engines or the number of FME Server cores, etc. to change, I'm leaving that fairly manual and static. With my dynamic engines, however, because that number of engines will probably vary, I've set my dynamic pool up with auto scaling enabled, and also these labels and taints. So the label means that if a pod matches the label with the property compute, it will get scheduled onto this node. But I've also tainted this node to make sure no other pods get scheduled onto it, only if one of the pods has a toleration for that taint, which you can see inside the values file. So you can see that the property compute matches the label that we have and that the tolerations are the same. So it's dynamic equals true. And then because auto scaling is enabled, Azure will be frequently monitoring the status of this node pool. If it sees that more pods are scheduled and there aren't enough nodes to take on that capacity, Azure will automatically add more nodes to that pool so that Kubernetes has enough resources for all of the pods that it needs. So this means if I want to scale up my dynamic engines, I only need to change and set that with my values YAML file. Azure and Kubernetes together will take care of the rest. So some of the other properties that we have inside the values YAML file are these engine properties. So you may have noticed on this engine management page, there's this list of properties here. So we provide some by default. So for example, the platform that it's running on, the build of FME, the type of engine that is running. However, with Kubernetes, you can add in more engine properties as a comma delimited list. So I've added CPU optimized as an engine property for this dynamic engine group. And then I've also added another dynamic engine group down here with a different engine property. This means that I can use these engine properties to assign different engines to different queues for my deployment. So the way that we can do that is by going to queues. This is where you'll create your queues. So I've created 2 new ones in addition to the default, so big processing jobs and a data streaming queue. And you can also set the priority here. So the lower the number, or closer to 1 the priority is, it means that these jobs will end up going to the top of the queue because they're higher priority. Once you've set up your queue, you can set up the job routing rules. So for example, I've got a contour processing repository which has some workspaces in. Any workspace within that repository is going to get processed on that big processing job queue that I created on the previous tab. You can also route jobs to queues based on metrics. We've started tracking workspace statistics such as percentage CPU utilization, CPU time, elapsed time, and peak memory usage. So you can also use those to direct your workspaces to different queues. The engine assignment rules is where you then choose which engines you want to be assigned to which queues. So in this example, any engine that has the property of CPU optimized is going to be added to the queue big processing jobs. So you can see for this engine group, which has the engine property of CPU optimized, if I increase this number to 20 engines, all of those 20 engines will automatically get added to the big processing jobs queue. And we can see that on this page. I didn't change the engines in here, which queue they belong to. That happened automatically once Kubernetes started those 2 dynamic engines for dynamic group 1.
So now adding on from our Kubernetes demo where we saw how easy it is to add dynamic engines to our Kubernetes deployment and see those scale up, we can see dynamic engines in action. So if we want to process data whenever we want and as fast as we want and make sure that we're only paying for the work that is done, we're going to use dynamic engines. So in the demo that's coming up, we'll have a workspace that puts a lot of load on the FME server or like increases the demand. And then we'll use dynamic engines, launch a lot more dynamic engines so all of those workspaces can get processed at the same time and reduce the queue a lot faster. We'll also see that FME Server dynamic engines are only used when needed. So we can have a look to see where you would watch that dynamic time be monitored in FME Server.
So if you're ever unsure or you want to check how many dynamic engine credits you have left, on the licensing page of FME Server at the bottom, you can see the section for dynamic engines. So the number of dynamic engines that you can run at any time is unlimited. You're not restricted for that. But the amount of credits that I have is listed to the left of that. So you can see I have well over 14,000 hours of credits available, which I'm not going to use all of those in this demo. I do, however, have an automation which we will use dynamic engines to process the data. So if we take a look at the automation, this is going to be triggered manually. I'll set this to run myself in a moment. And the first workspace is reading a directory and pulling out all of the contour shape files within that directory, and then passing those to the second workspace, which will process that contours data and output it somewhere else. So this first workspace will generate many jobs downstream in this one, which we will process using dynamic engines. So now let's go and trigger this automation. We can go and have a look at our running jobs page. You can see already it's starting to process those contours. And you can see that it's only processing 2 jobs at a time, but we have in our queue 21 jobs here. So if we want this to process faster, we're going to need to increase the number of dynamic engines that we have. So we'll go back to our values YAML file and do that. I'm going to increase this to 8. And then again, once again, use that Helm upgrade command to change my FME Server deployment. So if we go back to the engines page, we should start to see more dynamic engines appearing. And we can also keep an eye on the status of those pods in the command line. So we can do Kubernetes get pods. And I'm going to add this watch flag. So as the status changes, we'll see new lines appear at the bottom here. So at the moment, we can see quite a few dynamic engines are pending. These may also take a little while to start because if they currently don't have enough resources for Kubernetes to schedule them onto a node, we need to wait for Azure to scale up that node pool to make sure that there is enough capacity to cope with those engines. So you can see no more engines have started yet. We're still at 4 with 2 dynamic engines. But if we go to the dynamic pools page and refresh this, we should start to see the number of running nodes increase from 1 to 2. And now you can see that 1 out of 2 nodes are ready. It looks like it's starting up that second node. Oh, and you can see it's already scaling up pretty fast. It knows how many engines we need, so it can work out how many nodes it needs. You can see 3 out of 4, now 4 out of 4 nodes are ready. And we can also see in the terminal window that it's starting to create a lot more of those dynamic engines. So now we can go back and check our running jobs page. And we should see now that it's processing 4 jobs at a time. And as more engines start running, we'll see more jobs running at the same time. And there we go. We have our 8 dynamic engines all processing jobs at the same time. So now if we go and look in our queue, there's only 6 jobs left in our queue, so this won't take very long to process. So there's only 1 job left to finish processing. If we go back to our engines page, we can see that it's this one, as the job ID is linked here. And as soon as this is finished doing our big processing job, we can scale down our dynamic engines in our Kubernetes deployment, and Azure will automatically scale down the nodes as well. So saving money while those nodes aren't in use. So now that engine has finished processing that job, we can go back to our completed jobs page, and we can just see that all of the contour processing workspaces from this repository were processed on the big processing jobs queue by all those dynamic engines. then I'll just remember to scale this back down. And all of those engines will start to disappear. We'll be able to watch Kubernetes start to terminate all of those dynamic engines. There we go. And now we're back to our one dynamic engine as requested in our values YAML file. And after all of that dynamic engine processing, let's take a look at how many credits we used. So I'm now down to lots of hours, 11 minutes and 37 seconds. So that was around 30 seconds of credits that got used up, as we started on 12 minutes and 7 seconds. Whereas if you were doing this with standard engines, that would take you a lot longer. And if you wanted to do it concurrently with the same amount with 8 engines, that would also be a lot more expensive than 30 seconds of credits. So hopefully that shows you how using dynamic engines with a deployment option such as Kubernetes goes really well together.
And then just to sort of take things to the next level, this is a pretty intense Kubernetes deployment that was set up as part of the World Fair. So this was trying to see how many engines we could run on FME Server. So I think they got it up to 1,000 engines. And this is 1,000 dynamic engines to process a lot of data faster. And this is one thing to note as well with your deployments. You can see here that we have 4 FME Server cores to support those 1,000 engines. So if you're running a lot of engines, or even if you want high uptime with your FME Server, I do recommend having at least one FME Server core just for fault tolerance. But if you are planning on spinning up 1,000 engines, you do need approximately one FME Server core per 250 engines just to make sure that everything is running smoothly.
Yeah, so this shows graphically what's going on there. So on the left is one engine, and if you look closely, you'll see a dot appear every once in a while. And the idea, if you had one engine doing this work, it would take about 1 year. And on the right is with our 1,000 engines. And you can see with our 1,000 engines, as we're processing this data, it takes 1 hour. So what we've been able to do is take 1 hour of work and using 1,000 engines, turn it into to 1 hour of work. And yeah, and so if we look at the cost difference, you can see that here's a dynamic cost comparison. For what it's worth, it's it's humorous, really. If somebody did come to SAFE and they wanted to buy 1,000 standard engines, assuming that they paid full list price, it would cost 6.5 million US to deploy that. And the Amazon infrastructure cost is 100, that stays the same. But because dynamic engines, you're only paying for the work, we don't even sell by number of engines. So you could have as many dynamic engines as you want. We picked 1,000 for this demo. The number of hours each engine runs is an hour. The processing rate, if you buy a block, it was $1.50 an hour. So you can see that the cost to do all that grinding was $1,600. So you can see, the difference. Now, obviously, if you bought 1,000 engines, we assume that throughout the rest of the year you would do something with those engines. But this just shows, how dynamic engine brings a whole new way of thinking about data work to FME Server.
So just to recap, if you're looking to get started with FME Server and you want to maximize your FME Server deployment, first thing you're going to do is determine your organization's need for data processing and your budget. You'll then use that information to help you choose your FME Server deployment. And if you're not sure or you want more information, feel free to reach out to us and get advice. If you're looking at the cloud, you'll probably end up talking to me. And then once you've chosen your deployment, you're all set up, you'll start to save time and money with your data processing, workflows, and automations.
Yep, and some of the key takeaways today when choosing deployment, the first thing is to understand your workflows. Do you have big data lifts or spikes in your flow, your amount of demand on your system? If there are, then dynamic engines are definitely what to look for. Do you have the ability to scale? We talked about some deployments like Kubernetes that runs both on-prem and in the cloud. That is a great way to to scale. We also talked about FME Cloud, where you can vertically scale by launching a bigger machine and then reducing its size. Key, Jen talked about where your data is located. That's a very easy thing usually to determine, and really dictates some of your deployment options.
Yeah, so the other thing you're going to need to look at is your operating system or library dependencies. As I mentioned earlier, probably the biggest requirement that we see people using to sort of choose their deployment for them is whether they're using Windows-based formats. So a lot of people who are using Esri Geodatabase, for example, requires Windows, so that will rule out the Linux deployments. Also, what skills does your team have? So as I mentioned, Kubernetes is a more complex deployment. So even if it's the most attractive one to you, if you don't have the right skills on your team, it's probably not going to be a very successful deployment for you. So a lot of the customers that we've seen put Docker and Kubernetes in production do have the right staff at the organization to manage that for people. And are you already invested in a solution or cloud provider? So again, some people already have Kubernetes clusters set up, so it just makes sense to add FME Server to that. Or if people are using Google Cloud, they're probably going to want to use and put FME Server in the Google Cloud infrastructure that they already have.
Yeah, and so if after watching this, you want to experiment, because sometimes the only way to really know what's the best deployment is to try a few, and so contact us. Maybe FME Cloud is what you need. Maybe you're thinking you might need Kubernetes, maybe Docker Compose, or anyway, reach out to us and we can help you learn more. And we can also, you can try it and try a new deployment with dynamic engines. If you evaluate a FME server, we give you 100 hours of dynamic engines just so you can start to understand how they work and the value they provide. We also, on our website, we have one-on-one support with live chat, and so go there at safe.com. Also an amazing community of users. So yeah, lots of great next steps for you to help on your deployment path.
Awesome, thanks Don and Jen. We have a community badge here for everyone today as a thank you for joining us. So visit fme.ly/webinar badge, and today's code is on the screen, and I will leave that in the chat as well.
So thanks for attending. Lots of great questions. There's one around Python 2 versus Python 3, and I wanted to touch on that one because that is a really great question. FME, we now out of the box only support Python 3. If you want Python 2, you're going to have to install it yourself. The question about security is absolutely correct. Python 2 has major security vulnerabilities, and so we recommend everybody go to Python 3. Now, if you wrote code that ran on Python 2, there's a very good chance that it won't run on Python 3. So you will need to edit that code yourself and port it to Python 3. It's not a huge thing, but it is an issue. And the whole Python world is a bit nightmarish for us. There's Python 2, there's Python 3, there's ArcPy, there's and the ArcPy on the 32-bit Arc desktop is different than the ArcPy on Arc Pro, and we support them all. So again, if you're having trouble with that, don't feel bad. It is confusing, but do reach out to us, and we can help you get through that. But and so it is confusing. The things we're trying to make it as simple as possible for people, and things like that. Another good question, Jen. Somebody asked, what is the difference between dynamic engines and standard engines? So is there any difference?
Yeah, so we've had that question a lot, and people, I guess for standard engines, when you purchase your FME Server license, you kind of choose how many standard engines you want up front, and then that's how many concurrent workspaces you can run at one time. Yeah. But with dynamic engines, you're not buying an engine, you're buying time. So if you bought 10 hours worth of CPU time, you can basically run as many dynamic engines as you want that can use up that 10 hours. Obviously, if you're running 100 dynamic engines at once, you're probably going to go through that 10 hours of time a lot faster than if you're just doing one. But it's a lot more flexible.
Yeah, and you only pay for, so when they're idle, you're not paying, you're just paying for the work that's done. So, and functionality wise, they're identical. There's not anything that a standard engine can do that a dynamic, it's just purely the cost pricing model. And they're great for, there's a question about a data stream. Do data streams take up one engine? And the answer is yes. And in many cases, a dynamic engine's perfect for that, because your data stream often has really busy times or really quiet times, or maybe, you know, it's a stream, but it's not particularly got a huge number of features. So it's not going to keep an engine busy with the CPU. So because you're not paying for runtime, you're paying for CPU time. Dynamic engines often are pretty, are great with that, because we have lots of customers that have a stream and it might just be 100 features a second, and the CPU time versus is like 1 second for every hour of stream. And so with a dynamic engine, you're just paying for the 1 second of the CPU time. So yeah. So it's great questions around that. Anything else you want to see there, Jen?
Yeah, so I had a lot of people asking about like format support and third-party libraries with FME Cloud or Docker or Kubernetes. So with FME Cloud, well, with all of those three options, they're all based on Linux, most likely Ubuntu. So if your format requires Windows, it's not going to work. And with FME Cloud, as the end user, you don't have any access to the back end of that system. So you can't go on that machine and install any third-party libraries that you need. So if you need something like Esri geodatabase, that's not going to work on FME Cloud or Docker or Kubernetes. But with Docker and Kubernetes, you have a bit more flexibility, because you can take our engine images and then build your own image based on that. So if you need to add extra libraries in, like perhaps like different JDBC libraries or something like that, you can build your own engine image and launch that when you start your container deployment. But you are restricted to Linux.
Yeah. So yeah, fantastic. So yeah, and we answered a lot of the questions in the chat, and we're at time, and we'll be sure to follow up with all the questions. So and again, if you want to follow up further, this is the beginning of this discussion. This is a really relevant and growing topic for us, and there's lots of exciting things coming in FME 2023. And info@safe.com if you're not in the community and you would just like or live chat doesn't do it for you. So that's another great way, is to just reach out, and we're always happy to talk about anything data. So yeah, awesome.
Thanks everyone for joining us.
Yeah, thank you. Yeah, bye.
Bye.